Hello everyone. In this video, we will learn about new topic, that is complex numbers. In our previous classes, we learnt about the equations like x square is equal to 4. Having real solutions, x is equal to 2 and x is equal to minus 2. But the equation like x square plus 1 is equal to 0 has no real solution, as there is no real number which satisfies it. To solve this type of equation, we introduce the new number iota, where iota is equal to square root of minus 1 and iota square is equal to minus 1. So, a number of the form a plus iota b, where a and b are real numbers, is called complex number, where iota is equal to square root of minus 1. For example, 2 plus 3 iota, minus 1 plus root 3 iota, 7 by 2 iota, etc. For the complex number z is equal to a plus iota b, a is called the real part of z, denoted by, and b is called the imaginary part of z, denoted by. For example, if z is equal to 4 plus 5 iota, then real part of z is equal to 4 and imaginary part of z is equal to 5. Note: two complex numbers z1 is equal to a plus iota b and z2 is equal to c plus iota d are equal if and only if a is equal to c and b is equal to d. Algebra of complex numbers. Let z1 is equal to a plus iota b and z2 is equal to c plus iota d not equal to 0 be any two complex numbers. Then z1 plus z2 is equal to a plus c plus iota into b plus d, which is again a complex number. z1 minus z2 is equal to a minus c plus iota into b minus d, which is again a complex number. z1 into z2 is equal to ac minus bd plus iota into ad plus bc, which is again a complex number. z1 upon z2 is equal to z1 into 1 by z2, which is again a complex number. Note: for more details, go through our quick review section. After discussing algebra of complex numbers, now we will discuss the modulus and the conjugate of a complex number. Let z is equal to a plus iota b be a complex number. Then the modulus of z is equal to square root of a square plus b square. For example, modulus of 4 plus iota is equal to square root of 4 square plus 1 square, which is equal to square root of 17. The conjugate of z is equal to a plus iota b, denoted as z bar, is the complex number a minus iota b. That is, for example, conjugate of 4 plus iota is equal to 4 minus iota. Also, conjugate of minus 3 minus 5 iota is equal to minus 3 plus 5 iota. Conjugate of a complex number z doesn't affect the real part of z. Or we can say that conjugate of real value is real. Now, we will study about the representation of a complex number on the Argand plane. The complex number x plus iota y corresponds to the ordered pair x, y and can be represented geometrically as unique point p xy in the xy plane. And each point on the xy plane represents a unique complex number. The real part is measured on the x-axis and the imaginary part is measured on the y-axis. For example, 2 plus 4 iota can be represented graphically as shown. The plane having a complex number assigned to each of its points is called the complex plane or the Argand plane. In the Argand plane, the modulus of the complex number x plus iota y, which is equal to square root of x square plus y square, is the distance between the point p xy and the origin O 0, 0. The distance OP is called the modulus of z and is represented by, that is, OP is equal to modulus of z is equal to square root of x square plus y square. Let point P represent a complex number z is equal to x plus iota y on the Argand plane. Now join O and P. Draw a perpendicular PM on the x-axis. Let angle POM be equal to theta and OP be equal to R. In triangle OPM, OM upon OP is equal to base upon hypotenuse, which is equal to cos theta, which implies that x upon r is equal to cos theta, which further implies that x is equal to r cos theta, and PM upon OP is equal to perpendicular upon hypotenuse is equal to sin theta, which implies that y upon r is equal to sin theta, which further implies y is equal to r sin theta. So, z is equal to x plus iota y becomes r cos theta plus iota into r sin theta. By taking r common, it becomes z is equal to r into cos theta plus iota sin theta. This representation of complex number in terms of r and theta is called the polar representation of complex number. Now, by squaring and adding equations 1 and 2, we have x square plus y square is equal to r square cos square theta plus r square sin square theta. By taking r square common, we get which is equal to r square, which implies that r is equal to square root of x square plus y square, which is equal to modulus of z. By dividing equation 2 with equation 1, we get y by x is equal to r sin theta upon r cos theta is equal to tan theta, where theta is called the argument or amplitude of z and is denoted by, since tan of 2n pi plus theta is equal to tan theta, so value of argument of z is not unique. The value of theta such that minus pi is less than theta is less than or equal to pi is called principal argument and is denoted by method to find the principal argument. Step 1. For z is equal to x plus iota y, find the value of theta such that tan theta is equal to modulus of y upon x. Step 2. Look for the values of x, y. If xy lies in the first quadrant, then the principal argument of z is equal to theta. If xy lies in the second quadrant, then the principal argument of z is equal to pi minus theta. If xy lies in the third quadrant, then the principal argument of z is equal to minus pi plus theta. If xy lies in the fourth quadrant, then the principal argument of z is equal to minus theta. Note: for properties of complex numbers, view our quick review section.